The movement of the Earth around its axis and around the Sun is responsible for a lot of what we experience from day to day and month to month on Earth's surface. The Earth moves in two ways. It rotates and it revolves. Rotation refers to motion around its central axis, basically spinning, and revolution refers to moving around another object. Since the Earth rotates around an axis, a particular point on its surface, say where you're standing or sitting right now, faces the Sun at some times and faces away from the Sun at others. This is night and day. The part of the Earth illuminated by the Sun's radiation is experiencing day, and the part of it in Earth's shadow and shielded from the Sun is experiencing night. It takes approximately 24 hours for Earth to rotate once around its axis completely, so days on Earth are each 24 hours long. Planets that rotate slower or faster have different day lengths. The axis that Earth rotates around isn't vertical though. It's tilted approximately 23.5 degrees. This means that as it rotates, the north and south hemispheres may not receive the same amount of direct sunlight each day. As the Earth revolves around the Sun, the part of the Earth tilted into or out of the Sun's direct radiation changes. This means that the amount of total radiation that each hemisphere receives changes as the Earth revolves around the Sun, causing temperature, weather, and day length to vary between the hemispheres and from month to month. These changes caused by the revolution of the Earth around the Sun while on an axis are our seasons. During the summer, in the northern hemisphere, it is tilted more directly towards the Sun, receives more direct sunlight, experiences warmer days, and shorter nights. At the same time, the southern hemisphere is experiencing winter conditions. The day when the northern hemisphere receives the most direct radiation from the Sun, its longest day, is called the summer solstice or June solstice. The day when the southern hemisphere receives the most direct radiation from the Sun is called the winter solstice, in the northern hemisphere, or the December solstice. In September and March, both hemispheres receive approximately equal amounts of radiation from the Sun because the tilt is perpendicular to the Sun rather than aligned with it. In the northern hemisphere, these days will be called the autumnal equinox in September and the vernal equinox in March. We often call these the start of the seasons, though the meteorological calendar, which is based on the weather, has each season starting earlier than this. Most people living in industrialized nations, the length of the day and what season it is doesn't really matter beyond whether we have to go to work or school or not. However, to those living more agricultural lives and to ancient and tribal people, the movement of the Earth around the Sun was extremely important. Many ancient holidays and feast days were scheduled to coincide with the solstices, equinoxes, and the days halfway between them called quarter days. Many modern holidays still reflect this pattern, either because they hold roots in these ancient traditions, or because they still demonstrate the importance of the sun to modern man. Look at the list of holidays above and try to think of some holidays that take place on or near those dates. You should be able to think of a few. Knowing how the Earth rotates around its tilted axis and how it revolves around the Sun can help you navigate as well. As a result of the Earth's rotation, the Sun always rises towards the east and sets towards the west, but because of its tilt, this actually varies slightly. In the northern hemisphere, the Sun only rises and sets directly east and west on the two equinoxes. On the summer solstice, it actually rises and sets slightly northeast and northwest, and during the winter, it rises and sets more southeast and southwest. At noon each day, when the Sun is at its highest in the sky, your shadow is its smallest size, but you still have a shadow, which demonstrates that the Earth is tilted and the Sun isn't really directly overhead. In the northern hemisphere, your shadow will point north at noon. You can use all this information to estimate direction using the Sun. At sunrise, your shadow roughly points west. At noon, it roughly points north, and at sunset, it roughly points east. Between these periods, it points more northwest or northeast. If you own a watch with hands, you can use that to find a more accurate bearing. If you hold your watch in front of you as if you were going to read the time and then rotate your body until the hour hand points towards the Sun, if you draw a line in the dirt or imagine a line halfway between the hour hand and the 12, this line is approximately north and south. All you have to do now is figure out which side is north and which side is south. But you should be able to figure out that by looking at the time of day. In the afternoon, your shadow would be on the east side. In the morning, your shadow would be on the west side. If you stand so east to your right, then you're now facing north. North, south, east, and west are called the cardinal directions. Halfway between each of these are the intermediate or ordinal directions: northeast, southeast, southwest, and northwest. Directions can be further specified by going halfway between the cardinal directions and the ordinal directions. These small divisions would be denoted by saying the cardinal direction first, and then the ordinal direction. So, for example, halfway between north and northeast is north-northeast.